Hello Year 11 and welcome to what will be the third video in our second unit on driving safely. We're looking at stopping distance today, at how long it takes you to stop in an emergency essentially. Now, there are two components of this. The first is your reaction distance, which depends on your reaction time. If you are driving along and a tree should fall across the road, your foot will not instantly appear on the brake. There will be some small pause between you seeing something, this emergency occur, and you putting your foot on the brake. Okay, so reaction time, reaction distance. The second part of this is the braking distance, right? That's how far you continue to travel after you've put your foot on the brake. Putting your foot on the brake, right, does not bring you to an instant halt. It would be, in fact, very dangerous if it did. No, you slow down to a halt, okay, and you travel some distance during that. So we have our reaction distance and our braking distance. If we add those two things together, we get a stopping distance. Let's have a look at an example before we get too far along. And here we go. Madonna's driving along at 60 kilometres an hour. She has a reaction time of 1.5 seconds, and she sees a tree has fallen across the road. She puts her foot in the brakes and stops 17.4 metres after putting her foot on the brake. Okay, that's how we interpret this question. What was her reaction distance to the nearest metre? Well, our reaction distance depends on her speed and the time. Here is her speed, here is the time, but I don't want kilometres per hour, I need metres per second. Now to convert this to metres per second, I can convert this to metres, which is 60,000 metres. I can convert this to seconds, which is 3,600 seconds, and divide one by the other. Okay, and that will give me my speed in metres per second. But let me just tell you, because you'll do this a lot, to convert kilometres per hour to metres per second, divide by the magic number 3.6. So my distance is speed times time equals, I'm going to say 60 over 3.6, yep, multiplied by 1.5 equals, okay, calculator, where are you? Here we go. Ooh, look at that, 60 divided by 3.6, already there. Let's do it again though. 60 over 3.6 across times 1.5 equals 25 metres. Look at that, in 1.5 seconds, 60 kilometres an hour covers 25 metres. Beauty. Moving along with the next one. What is her stopping distance? Stopping distance is your reaction distance plus your braking distance. We've got the braking distance 17.4. We've calculated the reaction distance is 25. So 25 plus 17.4 equals 42.4 metres. Okay, there you go. Look at that. 42.4 metres is the quickest Madonna can come to a stop. What that means, really, at 60 kilometres per hour, if something should appear in front of her car that is less than 42.4 metres away, she won't be able to stop before she hits it. Okay? So, either you have to make sure there's nothing within 42.4 metres, or you have to go less than 60 kilometres per hour. Rightio. And in fact, yeah, I should bring this up because it's sort of the justification for this topic. That is why we have reduced speed limits in things like school zones and even in residential areas, because it doesn't matter how hard you try, you can't necessarily reduce these numbers. If you can't stop in less than 42 metres, right, then you need a buffer there in case something should appear in front of your car, perhaps someone walking out between a couple of parked cars, a small child or something like this, right? If they are less than 42 metres in front of your car when you see them, you won't be able to stop. Of course, these figures are sort of are fudged a little bit, right? They're made up a little bit, but they're reasonable enough. So, moving on here, use the braking distance formula. Here we go, this formula here. I think you'll be given that D equals KV squared. It explains this relationship between the stopping distance and your starting velocity, your initial velocity here, which is usually a u not a v, but anyway, we have some figures that we can substitute in there, and we will calculate a value for k. Now, we don't have to, when we're doing this thing here, we don't have to convert my speed in this case to meters per second. If you do, good luck to you, that's fine, it's perfectly fine, but it does save you a step. It means that k will always be, though, it will always be a constant that relates the distance in meters to the speed in kilometers per hour. Okay, I would normally say use a consistent set of units, but it does complicate this, so it does make these questions a bit longer. So, substitute in. Now we know that our distance was 17.4 equals k, don't know, times, now v squared. And we can just, as I said, we can use 60 squared here instead of 16.6 recurring, which we saw is our speed in meters per second. That means that k is 17.4 over 3,600, 60 squared. Therefore, k equals, whoops, that's not how I get to my calculator. Hello calculator, here we go, clear that away. 17.4 divided by 3,600 equals 0.0048. Two significant figures. 0.0048. Don't worry about units, but that is two significant figures. Right, we didn't have to round up to a 9, and these zeros at the beginning aren't significant figures. Now, moving along the braking distance, the nearest meter when travelling at 84 kilometres per hour. Okay, so now we can use k here, and I can say that d equals 0.0048 times 84 squared equals, back to my calculator. Come on, calculator, where are you? Here somewhere. Best really to carry that over without rounding it off if possible. I'm going to do that times 84 squared, and here we go, 34.1. I think it's this the nearest meter, so I'll say approximately equals 34 meters, nearest meter. Rightio, you can see in fact that has doubled it, or pretty close to having doubled it, from 17.4 to 34 by increasing your speed by that 24 kilometers per hour. Now, stopping distance, nearest meter when travelling at 84 kilometers an hour. My stopping distance is going to be my reaction distance plus my braking distance. My reaction distance hasn't changed. Okay, that doesn't change. So, oh yes, of course it does. What am I saying? My reaction distance, my distance is speed times time, is 84 over 3.6, yes, times 1.5 equals, oh boo, come on calculator, 84 divided by, oh no, 84 divided by 3.6. Okay, that's my speed in meters per second. It is important here that we use meters per second, times 1.5. Here we go. So we're going to do 35 meters there. Right, 35 meter reaction distance, and my stopping distance is that reaction distance plus my 34 meters braking distance equals, what's that, 69 meters. That's quite a long way. 69 meters travelling at 84 kilometers per hour. Now, moving on to part 4, the speed to the nearest kilometre per hour of a vehicle, the braking distance of 100 metres. Wow, what are we going to do here? Well, this is fairly sneaky. I'll give you a moment to think of a plan of attack here. We do know, what do we know here? A braking distance, oh, jeez. Oh, a braking distance of 100 metres. Oh, I thought we were going to have a stopping distance that was pretty mildly complicated, we'll be okay here. My braking distance, right? My braking distance, D equals kv squared. So I'm going to say D equals, was it 0.0048? 8 times a v squared. And I shouldn't have put a 100 here because we know that that distance is 100 metres. Now, I'm looking for an answer. It's going to be a little more than 84 kilometres an hour. Oh, yeah, no, in fact, it's going to be a bit more than 84 kilometres an hour, because at 84 kilometres an hour, our braking distance was 35 metres. Now, well, 34 metres. So now we're going to say that v squared is 100 over 0.0048, and v equals the square root of 100 over 0.0048. Okay, and back to the calculator. Just going to give me grief, isn't it? Come on, cursors. Where are you? Oh, that's not what I'm after. Calculator. Why'd you do this to me? Here it is. All clear. Why did I do that? Windows 10. Okay. Square root. Let's put the fraction in. 100 over 0.0048. All looks good. Yep. Equals 144 kilometers per hour. Remember that we calculated k with respect to kilometers per hour, so. Okay, at 144 kilometers per hour, it'll take you 100 meters to come to a stop once you put your foot in the brakes. Think about that now. Right, 144 kilometers per hour is too fast to be going. But how far is 100 meters in front of you on the road? Yeah, some way. Should you be exceeding the speed limit, think of how you could possibly, know that you can't stop within that length. Right, 100 meters is a fair way down the road. Okay, that's it for this video. It is pretty long. I hope you enjoyed it. I hope your calculator works better than mine, and I will see you in class.